triangles, then we talked about quadrilaterals. How many quadrilaterals are there that we have a name for? Does anybody know? 6 or 7? I think we had, if you go back, right, to this, page 25, you got 4, 5, 6, 7, 8 technically, but I wouldn't count a trapezoid in and of itself, because usually it'll be one of these two. But so 1, 2, 3, 4, 5, 6, 7 is what we're really having names for, right, specifically. And so make sure you have those on your study sheet, okay? And I need you to remember some of the properties of parallelograms, especially because they will ask you, in my opinion, very simple questions at times. So for example, when it comes to a rectangle, I don't think I have any rectangle questions here. Maybe let's go to 29 here. Go to page 29. There is a bit of a blank page. Let's go to the bottom of 29 and just copy this down, like just some examples here. So let's say the question, the province tells you this is a rectangle. And they go, okay? And you know that they show you that that's 5 centimeters. And then they'll ask you, what is WY? Like, what is that distance between those 2 points? If you have 2 letters, it's just basically the distance between the 2 points. You would have to, you should know that it's just 5 centimeters, that's it. Or if the question says, look at the following isosceles trapezoid, okay? And they tell you this. They tell you that this is 60 degrees, and let's label it A, B, C, and D. And let's say that this stretch here measures 100 millimeters. Okay? If the question asked you, what's the measure of AB? You should know it's 100 millimeters, okay? Like I hope it's a dead giveaway. So don't overthink it. This might be a little trickier. If I ask you what's the measure of angle B, what would you say? What's the measure of this angle right here? Do you remember what I told you? These two add up to what? Always add up to 180, like, because this line is parallel to that line, and angles that are between parallel lines always add up to 180, always, okay? We know that this is 180, therefore, this would be 180 minus 60 gives me 120 degrees, okay? So those are things that I would expect you to know. So some questions are just as simple as this, and then others you have to actually, sometimes they'll ask you to sketch and identify the properties. Either tell me what they are or mark them, okay? So let's go to 28 here. Sketching quadrilaterals. So sketch the following and clearly identify 2 properties. Make 3 versions of each example. I don't think that this is necessary, but I will give you a couple so that you know. This is on page 28. So if I ask you, sketch a kite and show me two properties of it, you should know what a kite looks like, sort of. Okay. For us, it looks like that. Not good enough yet. Not good enough. Not even, you would get 0 marks at this point. You have to identify one property. So one property we know about the kite is that these two sides measure the same, and these two sides measure the same. So that's kind of like one property there. Okay? Another thing you could say is that this angle and that angle are the same. So one pair of congruent angles. So two pairs of equal length and one pair of equal angles. You decide how you want to say it. You can use your own words, you can use symbols, you can use markings, right? Or another version could be, because remember, technically you should have these on your study sheet, right? You could talk about the diagonals. These diagonals meet at a 90, okay? And we know that the short one, okay, the shorter one that cuts across like this is bisected. Okay? We know that that one is cut in half. So we have that as well. Okay? So diagonals are perpendicular. That's one point that you can make. And the short diagonal bisects. I'm going to leave it at that. I'm not going to give you a third version. It just means that you could make it, you could identify any two properties and you'll be fine. Okay? A right trapezoid is probably one of the easiest ones to graph. There's not much to say about it. So, a right trapezoid looks like this. It's got 90s here on the one side, and these two lines are parallel. You're done. Okay? Two right angles and one pair of parallel sides. Done. So you either use markings or use a little, like, just identify it on the side using words. Okay. The parallelogram is like the umbrella of a bunch of other shapes. So parallelogram has a lot of options, right? You've got tons of options there. So a parallelogram looks like the slanted rectangle. The easiest version would probably be like this side is the same as that. That side measures the same as that. You've identified one property. Let's talk about the angles. What do we know about angles in a parallelogram? We know that opposite angles are the same. They measure the same. So this one gets 2 arcs. So 2 pairs of equal sides. 2 pairs of equal angles. And you have to make sure they're opposite, right? That's good enough. Another one you can talk about is the fact that If you want to talk about the diagonals, they do not meet at 90. That's not true. But you know that there's a long one and a short one. Okay? The long one gets cut in half. Okay, at this point, where they meet, right? They cut each other in half. And so this one is also cut in half, the shorter one. Diagonals bisect. And let's do parallel sides. Two pairs of parallel sides. You don't have to mark it necessarily, but I will. So this is parallel to that. This one is parallel to that side. That's all you need to do. And the list goes on. I'm going to say try page 29 if you want a bit more practice just with this, just sketching and identifying properties. All right. Okay. I'm gonna just do a couple here. Go to page 30. Given the quadrilateral below, which is a four-sided shape, it's asking what type is it, classify it. Classifying means name it, okay? Please don't leave it blank when it says classifying on the... So you should recognize that this is a trapezoid of some sort. Because these base angles being the same, okay, it's an isosceles trapezoid. Determine the values of angle A and angle B. So this one, I just talked about that, not like I actually used the exact same numbers, which I shouldn't have probably, but this is 120 here. We know that between parallel lines, those two angles are always adding up to 180. So it's angle A is 120, and B will also be 120, because there's also a 60 here, right? So angle B is equal to 120 as well. Let's maybe make in our notes, angles between parallel lines are always equal to 180. Okay, that's an important property that can get you out of a situation where you feel like you're stuck. Okay. The length of side AC. The length of AC is just this one here. We look at the other side as 4. There you go. All you need to say is that AC is equal to 4 centimeters. And the area of the trapezoid, I'm not going to do, because you're not expected to know how to do area of a trapezoid. So if you did it, way to go. But there's a formula there for that. You basically add, this is A, this is B, and the height of a trapezoid is this. Is like you got to figure it out using trigonometry, and that's how you would find out, but I'm not going to do it. Omit. I'm going to omit this, so that means don't worry about it. Let's keep going. 31 is very similar. If on 32 you were able to do everything except for C and D, you are also okay. Okay. I will do 33. Go to 33 here real quick. Got it? Determine the value of angle, watch that angle, X, Y, Z. Okay. There's a pretty high chance that they will throw at least one 3-letter angle notation at you. The very high chance, okay? So just make sure you connect them, right? X to the Y to the Z, right? So you connected those two sides, and then just think of the arc that connects those two sides. So they're asking you for that angle right there, okay? And basically, if this is, you know about a kite, you know that these two angles are the same. So all you would have to do is just say 101. That's it. But it just means that you have to know that, right? They're checking if you know the properties. That's all. Determine the value of WX. That's just side. Okay? Side WX. You know where WX is. It's just those two connected. That is 2 centimeters. That's easy as that, right? So there's not much to those ones, to be honest. C is a little trickier. That's where your trigonometry skills come in. Okay? So calculate the length of WY. So they want this. And XZ, this. So watch what I'm going to do here. I know that this is 2, and this is 2. I know that this is 3, and this is 3. I know that from the top, right? This one is a little controversial, this example right here. If you use this angle right here, which is 58, to calculate that, you're going to get a different answer than if you use this angle up here. Because we know that this is 101. We know this is 101. So we can go 360 degrees, which is all 4 added up, and subtract 101, 101, 58, to find this one, and then just do a side angle side with the top. You will get a different answer than if you use the bottom. That's not your fault, that is my fault, right? I wasn't careful when I made up the kite to make sure it all adds up, okay? I'm gonna use this one, okay? So that one is side angle side. Do you remember? So basically, I'm gonna say I wanna solve for that side right there. What should we call it? All letters are taken already. Let's call that M. That's side M. So I hope you remember how to solve for that. It calls for M squared. Actually, yeah, M squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 times cosine of 58. And I would invite you to all, if you didn't do this, type it in to make sure your calculators are still, you still know how to work it, okay? And so that gives you 8.46. So we take the root of 8.46. Take the root, that's 2.91. And we are in centimeters. So that's what you're supposed to get there. Let me just check. A completely different answer, right? What did I do? Let me check. It's 2.91, right? Am My key says 1.92, but that is just, sorry if you looked at the key and you were wondering what's going on, it's 2.91. Okay. And then you would do the same for this side here. If you're trying to solve for that side, if this is what you want, then I would use the 2 and the 3, and this is 101. Okay? And so we use side angle side here to solve for that one. Let's call that one n. Okay, give it a letter. And so n squared is equal to 2 squared plus 3 squared minus 2 times 3 times 2 times cosine of 101. So n is the square root of 15.2 something. So n is 3.91 centimeters. Okay. I think that's... I would expect you to know these types of questions. Now we're going to skip straight to 40. Okay, we're going to skip to page 40. And if you did everything in between, and you're like, wait a minute, I did all this work for nothing, don't think that. Don't think that you are honing your skills. It's going to be very helpful come exam time. Let's go to 40. And I want to give you a little bit of time to work through that. Okay? So I'm going to give you a couple minutes to go from 40. I'm going to just say 40 to 41. How's that? That's it. And then we're going to start polygons. 40 to 41 right now. If you did that already, just wait for us, and then we'll correct it. Okay. That's basically the last new piece. I mean, I won't cover everything that there is regarding it, but I'll get it started. So we're supposed to solve for the indicated side or angle and also classify each of these quadrilaterals. Determine the value of angle A and angle B, right? So there's a trick to this. This is 65, so is this one, right? So we know that opposite angles are the same. These are also the same. And I don't know if you recognize that this is a rhombus, right? So we know that this line is parallel to that line. And so these two add up to 180 degrees. Okay, so to find angle A, just go 180 minus 65. And that gives you 115 degrees. So angle A is 115. And B is, you can either just say they're the same, that's why I know that it's 115, or you can say it's 180 here as well. So angle B is 115 also. Okay, so boom, you got that solved. Let's classify it. It's a rhombus. Okay. All four sides are the same, and it's slanted like that, so in this case it would be a rhombus. Okay. Next one. This one looks like it's an isosceles trapezoid. Okay. And so what's the angle P here? What's this one here? Look at the whole shape, guys. If this is 3 and we get that these two are the same, well, obviously we bring the 3 over here. And it's asking for angle P. So we've got this triangle here, which is, right, we have a side, side, side situation. So to solve for angle P, we go cosine of P. Right, that's the side we want to have down first. These two are coming over here. and then it's 2 times 3 times 2.5. If you calculate the top, you get negative 9.75. If you calculate the bottom, you get 15. Okay, so angle P is the equivalent of cosine, inverse cosine of whatever you get here. If you divide them, you get 0.65 exactly. So angle P is 130.54 degrees. Can you please make sure you know how to do negatives? Okay, so my calculator allows me to go minus 9.75 divided by 15, no problem. It'll turn that into a negative decimal, and then I go shift cosine of that answer to get that. Okay, so it's an obtuse angle. We did know that because it's a negative here. It tells us it's obtuse. Let's see if you're awake during my classes. I'm not sure sometimes, talking to myself. If that top number is 0, if that had been a 0, what kind of angle would we have? What is it? If it's negative, it's obtuse. If it's 0, it's a right triangle, okay? Believe me or not, if that is a 0, 0 divided by 15 is 0, right? Inverse cosine of 0 is 90 degrees. Okay. If this is positive, if that top number is positive, what kind of angle do we have? It'll be an acute angle. Okay, so without even solving, you should be able to tell me, is it obtuse, is it acute, or is it right? Okay. That is what I was trying to do here. Determine the length of PR. PR is this, right? Let me see if I can do this with a ruler. Okay, PR, they're asking you for that diagonal. Okay, so PR is 5 centimeters. If it's 5 centimeters this way, it's going to be 5 centimeters that way. Both diagonals are the same. Okay. Next, determine the values of angle SQ and R. That should be easy. It's like easy for you to say, Mr. Dirksen. But S is the whole thing here. And we already know that this is 130 here. This is 130.54. So we know that these two add up to 180. So angle S is 180 minus 130.54. So angle S is 49.46. Boom, get that one down. Angle Q, this one over here, it's the whole angle. It's going to be the same as that one here because it's an isosceles trapezoid. So angle Q is 130.54. So whatever you got for P, that's what Q is. Angle R is the same as this one, 49.46. Okay? And there you have all 3 angles listed. Okay, so this was just trying to see if you understand the properties of a trapezoid. Fun stuff, eh? Ah, I know. You'll be losing sleep. Like I need to learn more about quadrilaterals. Can't wait. We won't do this one here. I did ask you to figure out the area. To figure out the area, you would need to calculate the base here, which you can do. You have enough angles and stuff to use sine law or whatever to figure out this base. I'm going to skip it because you're not expected to know how to do it. Mr. Dirksen, why would you put it in the booklet? If I have time, I usually do it, but we're running out of time, so I'll just leave that, okay? If you're interested in knowing the answer, I'll give you the answer. The answer is 10.15 centimeters squared. If you want to try that, you go for it.